finding the angle of inclination is really just finding the angle between flat ground or a zero slope and the slope of whatever line it is. So here's our slope of the first line, 2/3. So if we compare that with zero slope, there's zero slope. And to do 2/3, that's going up 2 and over 3. So there's that line. If I draw a little helping triangle, I know that this distance is 2, this distance is 3. So what is the angle here? Well, that's back to geometry when we learned to find the measure of the angle by doing the inverse of that angle. So we're doing inverse tangent of 2 over 3. And that comes out to approximately 33.7 degrees. Now, this is in degrees, so make sure the calculator's in degrees at this point. When we work on the second one, it's a negative slope. So here is ground 0. A negative slope goes somewhat like this. And that slope is -2, so it's a down 2 and over 1. So I can call this 1 and this 2. So we're looking for an angle that's got a tangent of -2. So the inverse tangent of -2 gives us a -63.4 degrees. And this should make sense in a unit circle. An angle moving this direction is considered positive, and an angle going in the negative direction is considered negative. Now, part C. We're looking for what is the measure of the acute angle that is formed at the intersection of the two lines. So if I kind of sketch the intersection of these two, the first slope, the 2/3, is approximately like this, and then the second one is approximately like this. And then here's zero slope. So we've got a 33.7 degree angle here, a 63.4 degree angle here. Now I'm not going to take into consideration the negative. So I've got this total here. Now the sum of these two is going to be obtuse. We're looking for the acute angle. So I'm going to find 180 degrees minus these two, and my acute angle is 82.9 degrees. All right, next question. Okay, sine, or the inverse of sine, inverse of cosine, and inverse of tangent are all functions because they have restricted ranges. Give the range of each of them. So to do this, we need to think back to the lesson where we were sketching the inverse of sine, cosine, and tangent. Sine, the regular sine, goes somewhat like this. When we sketch the inverse, it does this business. From here to here is our restricted range for sine. So for the inverse of sine, our range is from negative pi over 2 to right here, which is positive pi over 2. And that's inclusive, so we can use square brackets. For the inverse of cosine, that one's a little bit different. the inverse of cosine, when we look at that, instead of using the graph on this one, I'll take a look at the unit circle. On cosine, it was this portion that is included on the graph. And that's from 0 to pi. And for tangent, we'll go back to the sketch of tangent. Tangent has asymptotes at every pi over 2. And we have to restrict this to only one of these curves to make it a function. So when we flip this, we restrict from negative, oops, that was an error. We're going from negative pi over 2 to pi over 2. The reason that bracket was an error is because this is an asymptote. We're approaching those values. We never actually get to those values, so we need to use curved brackets on those. Alright, next. Given sine of angle A is 5 over 13, and secant of B is 5 over 4, and some information that helps us figure out which quadrant we're in. We're going to try to find exact values. So let's start with the sine of A. The sign is positive, and it says that the angle is also positive. I look at this, it says that A is above 0. A is above 0, it's positive. So I'm going to go ahead and sketch my triangle oriented as if it were in quadrant 1 and label this angle A. If the sine is 5/13, that means opposite over hypotenuse, 5 and 13. This is a Pythagorean triple. So by Pythagorean theorem, or just knowing that, this is a length 12. And this is great because then I can find that the cosine of A, what we want right here, cosine of angle A would be adjacent over hypotenuse, which is 12 over 13. 12 over 13. And for part B, what is the exact value of the sine of B? So B, it's different angle. We are told that B is less than pi over 2. Pi over 2 is up here, so I'm thinking again it's in quadrant 1. So here's another angle oriented as in quadrant 1. Here's angle B. Secant is the reciprocal of cosine, so I know that my cosine of B must be 4/5, because that's the reciprocal. So cosine adjacent over hypotenuse, 4 over 5. So Pythagorean triple again. I know this missing side must be 3. Therefore, the sine opposite over hypotenuse is 3/5. Now for the grand finale, part C. We've got cosine of the sum of angles A and B. At this point, we need to pull out our list of rules or have them memorized. This is a angle sum. So I have a cosine, so I see that it's cosine of A times cosine of B minus sine of A sine of B. So this part just came from my notes. Now I'm going to do some substitution from up above. I know that cosine of A is 12/13. I know that cosine of B is 4/5. I know that sine of A is 5/13. And I know that sine of B is 3/5. So now it's 5th grade math, 6th grade math. We are multiplying our fractions and simplifying. Our denominator is 65. And this product minus this product leaves us with 33. See ya at the next question, in the next video.